You guys here to learn? I'm drinking my coffee. It's been a long day, man. Look at the time. It says 6:30. It's p.m. It's almost my bedtime. I'm tired, man. All right. There is literally zero chance of me getting through this practice test without making 1 or 27 mistakes. So my guess, good time probably to pay attention and see if I made a mistake. It's been a long day, kids. I didn't even have the Pitman today, and I'm this tired. But that's okay. I'm zipping up the zipper, and I'm ready to rock and roll. By the way, just got done snow blowing. Again. Like, there's snow going all over my house. I had to actually get on my roof. Actually, not really on my roof, but with a rake, and clean off my satellite. Couldn't get TV. It's been a long day. Let's do some math. How long can you stare? I can stare for a long time. I'm not going to blink. Oh, shoot, I just blinked. All right, here we go. First couple, baby, right here. We're going to do a little bit of work with our calculator. So, ooh, that's kind of tiny. All right, so what we're going to do, we'll do a little bit of this review in class. I'm sure you'll get it. Let's go home, go to the calculator. Don't know what you're seeing, so let's get as much on there as possible. Okay, so I want to convert 32 degrees, 20 minutes, 35 seconds. Got a burp. Sorry, going to be drinking a lot of coffee. Got a lot of coffee. Made it strong, too. Woo-wee! By the end of this, I should be really crazy. All right, so I'm going to try to blow this up a little bit here for you, just so you can see. But I'm not having much success. Hold on. I just want you to be able to see this calculator better. All right, so, oh, maybe I can blow it up this way. Make it bigger? Nope. Okay. I want to put this in. Now, okay, so what we're going to do is maybe I can blow this up in the software. Not really sure I'm going to have time. But right down here next to the 9 button, everybody see my mouse flying around right here? Right down there next to the 9 button, there's this crazy button. It's the one we use fractions on sometimes. There it is right there. And there's our fraction button. There's absolute value button. Looks like that's a root button, a square root, cube root, any root, e to the whatever. Lots of crazy stuff in here. Matrices. We'll do those later. But this is the one right here we want. It's degrees, minutes, seconds. Kind of hard to look at, but that's degrees, minutes, second. We'll just click on that. And we will type in 32 degrees, 20 minutes, and 35 seconds. And we will hit enter. And I want to round this to the nearest degree. Oh, gotta love these calculators. All right, so enter. Doesn't like that. I should have guessed I put one of them in as a decimal. Go put a little decimal in there. And we click at 30. Now, it should come as no surprise. It's 32 degrees and some odd minutes. And we're going to round to a decimal in degrees. Round answer to 2 decimal places. All right, that's some really seriously crappy worded problems. How about round to the hundreds place? So looks like 32.34. 32.34. So we'll just write that in there. Hopefully, we've got to get rid of my eraser. Let's go with green. Green's kind of festive. 32.34 degrees. Wow. Done with 1. Wow. Freaking cruising. So now we're going to convert this to degrees, minutes, seconds. I don't know what I just did. Where'd my calculator? There it is. Anyway. All right. I don't know if you saw that, but I paused there for a second. I'll show you why later. I got something special for you guys. Little English lesson. 63 degrees, 63.18 degrees. So we're just going to convert that to degrees, minutes, seconds. So we'll go 63.18 degrees. Now, hold on. Let me just make sure I'm in degree mode. So highlight over there. Yep, I'm in degree mode. I'm in good to go. So what I want to do is I want to go to the, not this crazy button, but the catalog button next to it. Looks like a book that's open up. We'll click on that. And if DMS isn't selected for you, you got to be careful you're on the right tab. You know, and you might be up near the A's. Easiest way is just click on a D, drag, scroll down a little bit until you find DMS, and then just click DMS. And so we will DMS it. Doesn't sound right. All right, so This is 63 degrees, 10 minutes, 48 seconds. So let's see if I can click on that. 63, 10, 48. 63 degrees, 10 minutes, 48 seconds. Unbelievable. All right, so it says find the length of the arc subtended by the central angle of 30 degrees on a circle of a radius of 8 feet. What? Let's look up the word subtended. Based on the dictionary, subtended is a line, arc, or figure form an angle at a particular point where straight lines form its extremities are joined at that point. What? What are you talking about? Have bounding lines or points that meet or coincide with those of a line or arc. Oh, that makes more sense. Hold on. How about we just go with like Webster's Merriam online dictionary for subtend? No. To be opposite and to extend from one. No. Fixed angular extent of which respect to a fixed point on an object taken. This is why I teach mathematics. Somebody actually wrote this paragraph right here. And they think us normal people have any idea. Oh, wait. A central angle subtended by an arc. The angle subtended by the eye of an object. What? What? See ya! Wouldn't want to be ya! What do you need to know? We got length of an arc. Arc length. Arc length. There it is. Arc length. You guys need to know the formula for arc length. So let's do it. Let's do it. S equals theta r. By the way, it just means you have a central angle of a circle where this is 30 degrees and we've got some radius of 8 feet. How about that for some sick drawing? Whoa, huh? What? Okay, in order to use this angle, I'm going to get to a smaller pen because that's crazy. This thing must be in radians. You must remember that for test day. It must be in radians. So the first thing I got to do is take 30 degrees and I'm going to turn it into radians. Now I don't have a pi, so I'm going to include a pi. I'm going to multiply by pi over 180. Well, this turns out to be 30 pi over 180. And I'm drawing really huge here. Get rid of the zeros, we'll cast out those zeros. And 3 over 18 is really just pi over 6. So now I'm ready to rock and roll, but I have run out of space, so I'm going to grab the old eraser tool because I'm using a pencil. Not really. And what I'm going to do is I'm going to sub in. Well, I'm looking for, it says find the length of the arc. So I'm looking for the arc, so I have no idea. That S, remember, stands for the length of the arc, is equal to theta. Well, that's pi over 6 times radians. Now, it doesn't say to round it, so I could just say S equals 8 pi over 6. 8 pi. I'm getting hungry. This apple pie. Love apple pie. Apple Annie's. Wait, no. Wait, what's that across the street from the high school? Apple Annie's? Yeah, maybe. Oh, good apple pie. I don't know. Maybe I can do... Oh, what am I doing here? 4 pi over 3. What did I just write? But sometimes they want us, let's get this. Sometimes they want us to put this in here. So we're going to put this in our calculator. 4 pi buttons right there. Pi divided by trace. And I get 4.1887. So I could, if they wanted to, S equals 4.1887. Something to that effect. There you go. All right. The minute hand on a clock is 8 inches long. That's one really huge clock. How far does the tip of the minute hand move in 30 minutes? Okay. So this one is one of those, I'm going to trick the students. I'm going to trick the students. Questions. But you're smart because you have Mr. Krause for math. That makes you highly intelligent. First, for getting me for math. Lucky you. Second, because I'm gonna be like crazy. I'm like, there's my 8-inch minute hand. It's gonna rotate all the way over to here in 30 minutes. Do you agree? I thought you would. Nice. You see, I told you guys are smart. So, I know that the radius is 8. I know that it has traveled 180 degrees. Well, would you agree with me? This arc, along this red arc right here, is where it traveled. So this red arc from here to here is the distance it traveled. That's where the tip of the hand moved. So it's just an S equals theta r question. Well, r is easy. That's just 8. And theta is actually easy because 180 degrees, you all ought to know, is pi. So there's my answer. S equals 8 pi. Now, if they want you to take this and round it, if you want to grab this and put it in your calculator, just type in 8 pi. Once again, getting hungry, loving myself some pi. 25.1327. 25.1, where the heck am I going to go? 25.1327. Sweet. Ka-ching! All right. Convert each of the following, each of the following angles to degrees to radians. So really quickly, 135, you're going to multiply by pi over 180. If you multiply, now see what you want to do is, let's ignore this. We can get the calculator to do all this work for us. We'll just put in, I mean, this is the beauty of this calculator. We'll go in, we'll get a fraction. Oops, not DMS. We'll get in, get a fraction. And we'll just type in, I don't know why I'm up there, 135 over 180. And believe it or not, my best friend reduces it to 3/4. So 3 pi over 4 radians. All right, so I can do that same thing. I'll do it one more time, and then I'll just probably do these by hand over 180. Which is probably never a good idea. So we'll take in, again we'll hit that fraction. And it's 210 over 180. And the magic happens, 7 over 6. So this would be 7 pi over 6. Now I'll just do these by hand. I assume you can figure that out. We're going to take 18. We're going to multiply by pi over 180. So really what I have here is that. And 18 goes into 180 10 times. So this answer is pi over 10. And finally, 15 degrees. Just do it right here. We're going to multiply by pi over 180. 15 goes into 180 12 times. So this is pi over 12. Moving down. Let's go. All right, we're going to convert to radians. Now, I'm going to do the first tuple the way I've taught you. I know what you're thinking. It's coffee time. You know, if only I could taste this, it probably would be even better. Can't taste a thing. Can't smell a thing. Can't taste a thing. My life's not very good. And I got Pittman. Just saying, Pittman. Love you, man. Coffee. I'm going to be used up. All right, here we go. So what we do is... what we're really going to do is we're going to multiply by 180 over pi. I want to get rid of pi. Well, look what happens really. Watch this. Really, aren't I just replacing pi for 180? And the intelligent person's going, Doesn't pi equal 180? Pi, 180, equivalent. Can't I just rewrite it, get rid of the pi, erase, and put 180 in there? Absolutely intelligent person. Take your calculator. Boom, take your calculator and go. Now, you should know what this is. 3 divided by 4 times 180, and you should know that's 135. Boom. Why? Because we just did it right above it. 135 degrees. Now again, I can take this and multiply by 180 over pi and have the pi's cancel, but really I'm just replacing the pi with 180. 2/3 pi, 120 degrees. If you put in your calculator, you get 120 degrees. All right, so really what I'm going to do is I'm just going to replace that with 180. And that's 90 times 5 is 450. So negative 450 degrees. This is where I'm going to make a mistake. Mental math. I'm a little mental, and I'm doing mental math. And I need some more coffee. All right, so we're going to get rid of this, and we're going to replace it with 180. And if I do that, I get negative 270 degrees. Ka-ching! Finished. Keep moving. Okay, find the value of the 6 trigonometric functions of the angle and illusion. Illusion. Math is an illusion. Really it is. You like thinking, you go, wow, that's really easy. And then you're like, no, it's not. It's just an illusion. So let's see here. There's my pen. I'm tired of blue. I'm Hilton. Got to go red and black. Red and black. Black and red. Black and red. Black and black and black and red. Does anybody recognize hypotenuse? The hypotenuse is 13. One of the legs is 12. Do you guys recognize this as a 5, 12, 13 right triangle Pythagorean triple? It's one of those ones you ought to should have memorized. Ought to should. Whew. Seriously good English. Here we go. So there's my theta. I'm going to label this thing H, O, and A. Let's start rocking. So sine of theta. You got to hope like this. You get one like this on a test. Holy mackerel. Sine of theta. 5 over 13. Well, let's do cosecant right next to it. Cosecant theta. Because they go hand in hand. Hand in hand. Oh my gosh. Let's reverse that. We'll just flip it. It's the reciprocal. Boom, done. All right, next one. Cosine. Cosine of theta is equal to adjacent over hypotenuse, 12 over 13. So we'll go to secant theta because they're hand in hand. Oh, God, math is so much fun. And we'll take the reciprocal of that, 13 over 12. If there happens to be a parent watching in the background, and you think, my God, I send my lovely daughter or son to school to listen to that guy, I'm normally not this crazy. All right, I'm a little bit crazy, but I do teach the Pitman. I'm just saying. Ask Werner. She'll tell you. All right, here we go, kids. Tangent, opposite over adjacent, 5 over 12. 5 over 12. Cotangent would just be the reverse of that, 12 over 5. What do you think, huh? You guys going to ace this test? I hope so. You guys are awesome, man. A cute little angle. It's a cute little angle. Cute little angle. 90 degrees or less. No. I said that wrong. Less than 90 degrees. So we are in the first quadrant. Where in the world is my mouse? We are actually going to draw a triangle in the first quadrant because it says it's a cute little angle. So we'll draw a right triangle. Looks like that. Put in theta right there. And if I remember correctly, and I do because I teach math for a living, opposite over hypotenuse. So 4 over 5. So once the exact value of the remaining functions, and somebody in the background, probably Matt. Come on, Bishop. I know you were doing it, man. You're over there going, it's a 3, man! It's a 3, 4, 5 right triangle! You're the man. You're the man. You're the man. Whew. Need some more coffee. Put a 3 right there. Okay, this is the 3, 4, 5 Pythagorean triple. How easy is that? Let's label this O, A, and H. There's O. There's H. There's A. All right, let's go through it. Let's rock and roll. Sine of theta. Oh, we already know that's 4/5. Cosecant of theta is the reciprocal, 5 over 4. Then we'll go to cosine of theta. Cosine of theta is adjacent over hypotenuse. That would be 3 over 5. And we'll go secant next. Secant of theta is equal to the reciprocal of that, 5/3. And finally, tangent. Tangent of theta. Got a burp. Sorry. Just ate dinner. It was delish. I have no idea. I can't taste it. But I think so. I used to like it. 4/3. Adjacent, opposite over adjacent. And then we'll go to its cofunction, cotangent theta, and we'll put a reciprocal on that, 3 over 4. Rock on, kids. Woohoo! 14 problems, 13 problems done. It's a cute little angle. So we're back in that first quadrant. I should have been jerky. All right, we're back in that first quadrant. And there we go. There's a triangle. Now, you're going to find out this triangle is completely drawn. Well, first of all, it doesn't even look like a 90 degree. But second of all, it's completely drawn wrong. Remember, tangent is opposite over adjacent. So if I was actually going to draw a more accurate triangle, and probably a little bit more better looking. How you like that? More better looking. More better looking. I probably should draw something that looks more like that, right? Opposite over adjacent. Hypotenuse. We got to find that hypotenuse. 1 squared plus 4 squared equals x squared. Where's x? Right there. So this is 1 plus 16 equals x squared. I would really hope most of you can do this work by now in your head. I get x squared equals 17, or x equals radical 17. So you know we got some issues because we're going to have to do some rationalizing. All right, so let's rock and roll. Here we go. Sine theta. Sine theta is opposite over hypotenuse. 1 over radical 17. Multiply by radical 17 over radical 17. I get radical 17 over 17. Like what I just said was kind of like reading that paragraph on that website a few minutes ago. Like if you were not a mathematician, you'd be thinking square root of 17, square root of 17, 17 squared, square root of 7, 1 over 7 squared, square root of 17 over 17. What the heck did that dude just say? Let's do its cofunction. Secant theta. Well, I'm going to reciprocate this one because it's easy. It's just the square root of 17. Beautiful. Love it. All right, let's do cosine. Cosine of theta is equal to the adjacent over the hypotenuse. Well, you're going to see a theme here. I am not going to continue to rationalize these the way you should know. This is going to end up being 4 square roots of 17 over 17. And then I'm going to take its cofunction, which is secant, the lovely secant, and I'm going to take the reciprocal of that, square root of 17 over 4. Done. Paching. Now the good news is I'm done with radicals, so I don't have to do any more rationalizing. I already know tangent theta is 1 over 4, so therefore cotangent theta has to equal 4 over 1, or just a 4-bagger. Anybody ever go bowling? 4-bagger. Oh yeah, I've gotten a couple. All right, so here we go. I don't know. I'm trying to move down. There it is. I want to find the exact value. Now, I think I've talked to you about what exact value means, but should you happen to have forgotten what exact value means, this thing right here, ooh, look at the way I can just highlight there with my highlighter tool. Oh my God, these computers are so amazing. Let's go to black. No, let's go. I got to make it red because I got to drive home the point. No, stupid machine. And I don't even know if I spelled that wrong, so I'm just going to erase it, pretend like I can't see it. No, stupid machine. Okay. Never, ever should you say something stupid, because you never want to do that. So let's do this. No calculator. Oh, do not use calculator. I didn't even see it was in there. Oh, yeah. Okay, so let's see. Pi over 4, I think we talked about in class now. If you have a 4 in the denominator, the reference angle is going to be 45 degrees. And this is in the first quadrant. So this is really the tangent of 45 degrees. You could also just put in 180 there. 180 divided by 4 is 45. Minus the sine. Now, again, when there's a 6 in the denominator, that's a 30-degree reference angle. So this is really the sine of 30. Now, hopefully by now you've memorized that the tangent of 45 is 1 and that the sine of 30 is 1/2. So my answer here is simply 1/2. 1 minus 1/2 is 1/2. Cosine of pi over 3. Well, if you put in 180 for this pi, you'll find out this is 180 over 3, or 60 degrees. So that's the cosine of 60 degrees, plus the sine, again, put in a 180 here, of 90 degrees. So the cosine of 60 is 1/2. The sine of 90 is 1. I don't know why I got such burpages. So 1.5. There we go. Moving on up. Oops. So 3 sine 45. By now, you should know that the sine 45 is the square root of 2 over 2. I cannot get rid of these hiccups. Maybe it's coffee. Whoa. Can you hear me? Can you hear me now? Gotta check my mic. Check mic check. Just accidentally turned off my mic. Almost spilled my coffee. 4 times. Oh, wait a second. This is going to be 30-degree reference angle. Tangent of 30 degrees is the square root of 3 over 3. All right, so this really becomes 3 square roots of 2 over 2 minus 4 square roots of 3 over 3. Cheap. And we need a common denominator to add these. Our common denominator will be 6. 6. So I got to multiply this one by 3. So I get 9 square roots of 2 over 6 minus, and you got to multiply this one by 2, 8 square roots of 3 over 6. So my final answer is, you can't combine those, 9 radical 2 minus 8 radical 3 over 6. Kind of crazy. Crazy! Sine of 60 is, you should know this, the sine of 60 is the square root of 3 over 2. Plus 3 times, now, make that 180. 180 divided by 3 is 60. Sine of 60 is radical 3. So we're going to have to combine these. These ones are going to get actually combined. So let's see what we got here. We're going to get, let's see, that's 2 goes in there twice. That gives me 2 square roots of 3 plus 3 square roots of 3 for a grand total of 5 square roots of 3. Ka-ching! Done! Use your calculator to approximate secant of 10 degrees. So take out our calculator. Now, if you remember, secant's going to be right here under the trig. Right here under the trig. Trig and secant. 10 degrees. Make sure I'm in degree mode. Yep. Hit enter. 1.015. What is it? To the nearest hundredth, that's going to be 1.02. 1.02. Done. Find the exact value of the 6 trigonometric functions for theta if 3, -4 is a point on the terminal side. So, you remember what I said in class? You got a point, plot a point. So let's do this. Let's rock and roll. 3, -4. 1, 2, 3. 1, 2, 3, 4. There's my point. And this is now my terminal side. What axes do we draw our triangle to? Oh, X, you say? You must have Mr. Krause for math. That's how smart you are. Holy mackerel. Nobody else would have gotten that answer right. All right, so there's the point 3. So didn't I come over here 3 and down 4 to get to that point? Here's a 3, 4, 5 right triangle, Mr. Krause! Woo! Man, somebody screamed that out. I know you did. 3, 4, 5 right triangle. There it is. And there's my theta. Let me throw some black in there. A little black and gold. Nope, black and red, black and red. This is my opposite side. This is my adjacent side. And this is my hypotenuse. So it's very easy to go through these functions. Sine theta, cosine theta. I hope you did this already. Tangent theta, that's a tangent theta. And then we'll go through their cofunctions. Cotangent theta, secant theta, and cosecant theta. Ka-chang, ka-chang, ka-chang. All right, sine, opposite over adjacent. Nope, hypotenuse. 4 over 5. Flip it. 5 over 4 for secant. Cosine, 3 adjacent over hypotenuse. 3 over 5. Flip it. For the secant, 5 over 3. Tangent, opposite over adjacent, 4 over 3. Didn't do it. Gotcha. 3 over 4 for the cotangent. What do you think? You guys rocking it? Rocking it out of the park? All right. Name the quadrant that theta lies in if cosine is, what does this mean? Positive. Beautiful. And what does this mean? Negative. So we'll come over here to our axes. Ka-ching, ka-ching. What is that, Krause, man? Krause. That looks like... Nope. That looks like Noah's drawings. Yeah, I don't know if you know, but Noah's not much of an artiste. I'm just saying. Neither am I. Okay. So, cosine is positive. Cosine is positive here. Everything's positive there. and here, because it's the x values, and the x values are to the right. Cosine always represents or works with the x values. And tangent is negative. Well, tangent is negative. Let's see. All students take calculus. Tangent's positive here and here. So it must be negative here and here. Why did I just do that? It's not negative there. What's not negative there? That's craziness, Kraus, man. It's negative down here. And I want where it's negative. So I want where cosine is positive and tangent's negative. That would be quadrant. Four bagger. You guys ever gone bowling? Four baggers when you get 4 strikes in a row? Oh, yeah. Let me know when you do that. Find the reference angle for pi. Oh, my gosh. Okay, kids. So smart people, only smart people. If you're not smart, just kind of fast forward a little bit. I'll go like this when I'm ready for the dumb people. I don't have any dumb people. What are you talking about? Aren't I just pi over 5 away from 5 pi over 5, which would be pi, which would be on the axis? So you could simply just say pi over 5 is my reference angle. You could say that's going to be, grab your calculator and go, okay, 180 divided by 5, which we're going to be doing later anyway, 36 degrees. You could say 36 degrees. Okay, but let's say you don't understand that. Let's say you're sitting there going, okay, Kraus, what the heck did you just do? Because I really don't even understand that. Okay, so for all the rest of you, let's convert this to degrees. We're going to multiply by 180 over pi. We're going to get rid of that nasty pi. Pi's cancel. And I end up with this equal to negative 144 degrees. So I grab my thing here, my this is going to be a freaking long night. All right, so I grab my coordinate axes, I draw in a negative 144 degrees, and lo and behold, just like I said before, I am 36 degrees away from that. So my 36 degrees is my reference angle. Moving on down. Find the exact value of sine, cosine, and tangent if this is a point on the unit circle. Why would that be a point on the unit circle? Well, all right, let's go with the fact that they said it's a point on the unit circle. I'm not really sure why they would say that's a point on the unit circle. Really not a point on the unit circle. Well, whatever. Whatever unit circles it is, it is. Okay, so if it is on the unit circle, then this is the x value, which coordinates or corresponds with cosine. So cosine of theta would be negative 3 over 5. Sine of theta would correspond with the y value, or 4 over 5. And finally, tangent of theta, hopefully you've now mastered this, is really sine theta over cosine theta, which is, do you feel like an adult, like you're like this, I'm doing some mathematics now, like, hello, I'm ready to freaking launch a nuclear weapon or something, I'm so good. We're just going to divide those. Sine over cosine, so 4 over 5 divided by cosine, which is negative 3 over 5. Now, I talked to you in class the other day, when you have a fraction divided by another fraction, we're just going to flip and multiply. So really what we're going to do is flip this and multiply. 5 over negative 3. Negative 3. So the 5s will cancel, and I end up with negative 4 over 3. Ka-ching! Done with 23. How many problems do I have to go through? Because I'm getting old. 32. Ooh, I'm almost there. Krausman. Coming. Where is the thing? Okay. Alright, so hopefully these are easy. Find the exact value of each of the... Oh my gosh, Kraus, you're killing me. Alright, so these are kind of tricky. Let's get rocking on them. Okay, first things first. I got to figure out which quadrant I'm in. Tangent is positive. Okay, that's going to be here and here. Sine is negative. Okay, that's going to be here. And, well, okay, there we go. We already know we're in this quadrant right here. So let me draw my triangle in this quadrant. Tangent is opposite over hypotenuse, opposite over adjacent. So I'm going to put my 12 over 5 over here. 5, 12, 13, Mr. God, 3, 4, 5, 13, 5, 12, 13, right triangle. Did I wake anybody up? I'll bet I did. So 5, 12, 13. Okay. Sine, theta, cosine, theta, tangent, theta. Well, I already know tangent theta. That's 12 over 5, which then, of course, then I know cotangent theta. That's there. That there must be equal to 5 over 12. Cosine, let's see, we'll secant theta over here. Oops. And then cosecant theta over here. Wait a second now. This is what I'm talking about, kids. Let's talk. We have to worry about sines. And in the third quadrant, you got to remember, wherever my mouse might be, that sine and tangent are negative in this quadrant. So sine and cosine are negative. So I got to put my negatives right here on all my cosines and my sines. Let's see. Sine is opposite over hypotenuse, so that would be 12 over 13, negative 12 over 13, so this would be negative 13 over 12. Cosine is adjacent over hypotenuse, so it would be negative 5 over 13, or negative 13 over 5. Rock on, brother. All right. So let me put I'm going to do this a little bit differently. I'm going to put this axis up here. Secant, otherwise known as the reciprocal of cosine, is negative. Cosine is negative in the second and third quadrant. Tangent is negative. Well, tangent is negative in the second and fourth quadrant. So we're looking at a second quadrant triangle. So what we're going to do is we're going to draw our second quadrant triangle. Cha-ching. Make it try to look like a right triangle. Theta goes right here. Grab some different color. And let's see, secant. This is confusing me. This is confusing. I'm confused. So cosine would be, let's do those right now then. Cosine of theta, coup of theta, we'll go coup of theta instead of cosine, because coup of theta sounds much cooler than cosine. So, cooter. That was for the adults. They'll know what that means. Cosine of theta is just the reciprocal of secant theta. So we're going to write that as negative 4 over 5. And then secant theta we know as negative 5 over 4. All right, so let me go over here. Now cosine I know. There's the 4 adjacent over hypotenuse. 3, 4, 5, right time, Mr. Chris! Dude, you are freaking rocking it. Loving you, man. Love you guys. Not really. That'll get me sued. Don't tell anybody. I do like you guys, though. I have a great group of kids this year. Let me take a coffee break. Except for you, Pitman. You're super awesome. JK, bro. All right, sine of theta. Here we go. We're rocking and rolling, brother. Sine of theta is opposite over hypotenuse. 3 over 5. Why am I having a hard time finding my pen? 3 over 5. And then cosecant, there it is, theta would just be the reciprocal 5 over 3. Let's see. Sine in the second quadrant is positive. We're good there. And let's go tangent of theta. Tangent of theta is opposite over hypotenuse, or opposite, I keep doing that. Opposite over adjacent, or 3 over 5. 3 over 4. Whew! 3 over 4, but sadly to say, it's negative in this quadrant. And finally on this problem, cotangent of theta is equal to negative 4 over 3. I hope this is a more difficult one. I need a challenge. So cosine of theta is 3/5, and we're in the third quadrant. Wow, that was nice of them. So I'm just going to draw me a triangle in the third quadrant. Always, 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 always make your triangle with the x-axis. So let's see. Cosine is adjacent over hypotenuse. So adjacent over hypotenuse. 3, 4, 5, right. Man, that's like the 45th time that's come up. So, oh, wait. I was so excited about saying 3, 4, 5 right triangle. Oh, man. This thing's going to take forever the way I'm drawing stuff. Whee! There we go. All right. So, wait a second. Oh, yeah. I'm losing it, man. As it goes to 5, we're going to put a 4 right there. 3, 4, 5 right triangle. Maybe I should just settle down. Calm down, man. Simmer down, man. All right, so let's just tackle cosine theta real quick. Cosine theta is negative 3 over 5. I was given that. Therefore, secant theta is, oops, forgot the theta, is negative 5 over 3. That's a 5, by the way, just in case you're wondering. Now, the other thing I want to think about right now in this quadrant, I'm going to do it right now, is sines are negative. Don't forget, that's where you guys are going to miss all your points. You're going to mess up the sines. You're going to do some really cool work, and then you're going to do some Krauss stuff, otherwise known as some dumb mistakes. You don't want to make dumb mistakes. You want to make smart mistakes. Wait, no, you don't. You don't want to make any mistakes. So tangent of theta, and tangent in the third quadrant is, oh yeah, that's right, take calculus. That means it's positive. If you don't know what I mean, you should. Cotangent theta. All right. So let's see. Sine is a opposite over a hypotenuse. 4 over 5. And we'll just reciprocate that for this. Yeah, lots of hiccups. And then tangent is opposite over adjacent. 4 over 3. And then we'll just flip that 3 over 4. What the heck does that mean? Are you joking me? Krauss, you trying to trick me, man. I know pi is 180. And 3 pi over 2, I know that by now, is 270 degrees. So that puts it in the third quadrant. You tried to trick me, you son of a so-and-so and such and who and what you will call it. So we'll draw a triangle again in the third quadrant. Again, I don't know really what cosecant is, but I do know a lot about is negative 4. So I do know a lot about sine, and sine is going to be the reciprocal of that, which is negative 1 over 4. This is negative 4 over 1. That's 4. So that means it's, since sine is opposite over hypotenuse, I'm going to put the 1 there and the 4 there. And through a little bit of magic and some work, I'll find out that this is equal to the square root of 3. Because 4 squared minus 1 squared is 3. And the square root of 3. So let's do cosine is also going to be negative here. So, oops, forgot the theta. And that will be negative square root of 3 over 4. And secant will be the reciprocal of that, which is 4, actually, negative 4 over the radical 3, which is just, oh my gosh, I'm so out of room. Negative square root of 4. All right, I'm just going to tell you what it is, because now I'm being annoying me. Now I'm annoying myself, because I started over there. So secant, and I'm drawing with the big pen. Secant theta, it would be 4 over the square root of 3. Negative 4 over the square root of 3. So it's negative 4 square roots of 3 over 3. And finally, tangent, tangent is 1 over theta equals 1 over radical 3, which is really just radical 3 over 3. And that doesn't make any sense. Opposite over adjacent, 1 over radical 3, and if I rationalize that, I get radical 3 over 3. Okay, that's fine. Radical 3 over 3, yeah. And then cotangent would just be radical 3. All right, moving on. So these problems are actually really simple, but they look complicated. Here's the trick on these problems. You got to realize you're on the unit circle. That's key number 1. You're on the unit circle. And you got this pair x and y. Now that, if you remember all that stuff from the unit circles, all those things, you ought to be able to tell what's going on here. So first thing I'm going to do is figure out how many degrees this is. And when you do that, you're going to find out that this is 120 degrees. I hope you can convert, multiply, get rid of the pi, put 180 in its place, and do it. So 120 degrees. Well, that makes a reference angle of 60 degrees. So, if you remember that x is the cosine and y is the sine, then x is equal to whatever the cosine of 60 degrees is in the second quadrant. So that means it's going to be negative there. So, let's see, cosine of 60 degrees. Oh yeah, that's negative 1/2. Well, cosine of 60 is 1/2. So therefore, so this is y. Y is this value, and the sine of 60 is the square root of 3 over 2. Done. Moving on. So 7 pi over 6. Once again, we're just going to convert that to degrees. And what you'll find out is that's 210 degrees. I'm not going through that process with you. Puts us in the third quadrant. That gives me a reference angle of 30 degrees. And then again, x is the cosine, so the cosine of 30 degrees is radical 3 over 2, but I'm in the third quadrant, negative. That's where you're going to make your mistake. Y is also going to be negative because I'm in the third quadrant, and we'll do 1/2. Done. Pi over 3. That's 180 divided by 3, or 60 degrees. Okay, notice we're in the first quadrant. What is the cosine of 60 degrees? Well, we've already done this. It's 1/2, and we're in the first quadrant, so it's just 1/2. And then y would be... why did I make these all so easy? I thought I had a harder one in here. But anyway, y would be... square root of 3 over 2. All right, so the next one is 4 pi over 3. 4 pi over 3 puts us in the third quadrant again. Puts us again with a 60-degree angle. Like I said, I don't know why I did all these, but whatever. X is the cosine of 60 degrees, and the cosine of 60 degrees is 1/2. Whatever. Kind of silly. But we're in the third quadrant, so it's negative, and then y would be negative radical 3 over 2. I meant to put 1 as square root of 2 over 2, but notice it would be the same thing. If this denominator was a 4, wouldn't the reference angle be a 45? And then you can just use the square root of 2 over 2 and the square root of 2 over 2. All right. Oh, my gosh. Seriously? Yeah, I thought I had less problems. And look, all of a sudden it's saying you got these millions of questions. Okay, so let's go back to our reference triangle of 30 degrees. Bam, bam, bam. 30. Up, 2, 1, square root of 3 to remember. So we're going to write 18 over, or x over 18 equals 2 over radical 3. All right. So x times radical 3 is equal to 36. Divide by 36, or divide by the square root of 3. These cancel. And then I got to rationalize this by multiplying by radical 3 over radical 3. And I get 36 radical 3 over 3, which is really just 12 radical 3. Moving on. All right. No work. It's 12. But if the x was here, if the x was there, what I would do is draw me a 45, 45, 90 right triangle. And I put 2 here, and the square root of 2 is out here. And I'd say, okay, 2 over the square root of 2 is equal to, and that was if, I should call this y, just to kind of show you it's different, y over 12. And then cross multiply, and I get 24 equals the square root of 2 times y, divide by the square root of 2, and I get y equals 24 radical 2 over 2, and I get y equals 12 radical 2. Done. I think my pen's dying. I hope we finish quickly. All right, so let's draw this kind of similar. 1, square root of 3, and 2, and I want this side here and this side here. So x over 15 equals 1 over radical 3. So I get 15 equals x times radical 3, divide by radical 3, and then I rationalize by multiplying by radical 3, so I get 15 radical 3 over 3, which is equal to 5 radical 3. And finally, let me draw my 45, 45, 90 reference triangle. Remember, this is 2, and these are going to be the square roots of 2. So I get x over 20 equals the square root of 2 over 2. Or 2x equals 20 radical 2. Divide both sides by 10 or 2, and I get 10 radical 2. Done. I think I screwed up this. There's 30, 31, 32, 33, 34, 28, 29, 30, 31, 32. Oh, man. I was so excited. There's only like 10 problems left, and look what happened. I screwed myself up. Yeah, that stinks, man. All right, we got a hot air balloon. There's my balloon. What a sick artist I am. It's got a 250-foot cable tethered to the ground. Makes a 52 degrees, 20-minute angle. How high is the balloon? So we're going to look for, here's my balloon. We're going to look for X. So it's a 250-foot cable, so I have to put the 250 foot here. What you want to do is grab out your pen, label this O, A, and H. It looks like I'm using O and H. Haven't looked at you guys in a while. I'm burning up. I'm like breaking down. I'm like not airily. Oh, I don't even know what I'm saying anymore. I hope I haven't made too many mistakes yet. I think I've been pretty good. So what we're going to use is the sine function, because that's opposite over a hypotenuse. So sine of 52 degrees, 20 minutes, equals opposite x over the hypotenuse 250. And we're going to cross multiply. So I get x equals 250 times sine 52 degrees, 20 minutes. And I think I forgot to tell you where to round to. Oh, to the nearest foot. So we grab our calculator and we'll type in 250 times sine, where the heck is sine? Sine of 52 degrees, 20 minutes. Remember, to put that in, I got to go to this complicated button. And even though we can just ignore the fact that there's seconds, see how it's grayed out? Grayed out means really not, if you don't put anything in there, doesn't even know that there's something there. Or pretends like it's blank. 52 degrees, 20 minutes. And if I just press enter now, it's going to tell me it's 197.89. So I should write that down, 89479. 197.89479. 89479. Go back up here. It says to the nearest foot, 197 feet. Moving on. Helicopter is in search. Its search beams directed on a point observes at the angle of depression. So this is one I haven't talked to you much about. Here's my helicopter. I ever tell you about the time I flew in a helicopter? I was coming back from Iraq. I drove in a Chinook. It's the one with the two prop helicopters. There was like a tank in there. It was cool. It was cool. So awesome. Coffee time. Here's the problem with elevation angles of depression. Depression means they're going to go down. So if this is where the pilot's looking straight out, and then he's going to put a search beam. He's going to put a search beam down, and it's directed to a point on the ground. Okay? So what we're going to do is we're going to draw in the angle of depression. Well, okay, he's looking down. Let me put the ground down here. So he's looking down. There's the spot on the ground that he's got his laser beam pointed at. And it says that the angle of depression, well, depression angles start at the top and come down. So that angle of depression is 32 degrees, 10 minutes. So you got to remember that. Angles of depression start here and they look down. Angles of elevation start here and look up. So this is an angle of depression. If the length of the beam of light is 840 meters, now this is real true life mathematics because everybody can measure the length of a beam of light. Okay, but it's 800. The length of the beam is 840 meters. Find the altitude of the helicopter. So this would be the altitude of the helicopter. Even though I'm drawing it way over here, it's still the altitude of the helicopter. So I'll call this x. Take out my red tool. We'll label this O, A, and H. This is O, this is A, this is H. And once again, we're going to be using sine. So sine of 32 degrees, 10 minutes, is equal to x over 840 degrees, or 840 meters for that laser beam. We're going to cross multiply. Like X Games. Cross multiply. So x equals 840 times sine, my pen's dying, 32 degrees, 10 minutes. Put it down for a second, use my mouse. So 840, so 840 times sine, I forgot the 40, yes, I know that. 840 times sine, 32 degrees, 10 minutes. So I got to get to this crazy button again. Get the crazy button. 32 degrees, 10 minutes. Okay. 32 degrees, 10 minutes. So there it is. 447.202. So x equals 447.2024 and we want to round it to the nearest meter, so my answer is x equals 447 meters. That's how high the helicopter is. Amazing real life problem. How high above the ground to the nearest tenth is the ramp? So really we just want to find the wall here. Oh my gosh. I took out some of these word problems. I should have actually paid more attention to which ones. This one's going to be sine again. Opposite over hypotenuse. So sine of 32 degrees is equal to x over 30. So I'm not really going to go through this too much. It's 30 times sine 32. So 30 times sine 32. I don't know how it does that. 32. Enter 15 instead of nearest tenth. I'm just going to round it 15.9. I'm just going to do that right now because I'm tired. 15.9. That's done. All right. Oh, we're looking for x. All right, so if we're going to look for x, I knew I kept this in for a reason. That's what we're looking for. This is opposite, and this is adjacent. That's tangent. So we're going to do tangent of x equals opposite, which is 280, over adjacent, which is 170. Now, if you remember correctly, we have to use the inverse tan function, or as we're going to come to find out later on, they're called the arctan. But really what we're doing is we're just going to slide that tan over. We're going to take the arctan of both sides, or the inverse tan of both sides, and we're going to find out that x is equal to tan negative 1 of 280 over 170. Please show your work. Show that you know what you're talking about. So we'll go over here. We'll go tan negative 1 of 280 over 170. So give myself a fraction. 280 over, I think it was 170, wasn't it? 170. And hit enter. 58.736. So x equals 58.736. I can't even remember a couple numbers at this time. 268, something like that. 268. Rounded to the nearest degree. The answer is 59 degrees. I feel like I've done that problem before. All right. I want to know the tower. So I want to know the tower. Ooh, wait, it's not a sine function. So x. So we're going to do tangent. Why tangent? Because this is opposite and this is adjacent. So tangent of 78 degrees is equal to opposite, which is x, over adjacent, which is 25. Cross multiply, I get x equals 25 times tangent of 78 degrees. Bust out the calculator. 25 times tangent 78 degrees. Wasn't it 78? 78 degrees. Enter 117.615. 117.61575. 61575, whatever. To the nearest tenth of a foot, we're going to go with 117.6 feet. All right, communicator. Find to the nearest degree the measure the angle makes. The wire makes with the ground. So wire and ground. So here's the wire, there's the ground, there's my angle. Label this puppy. I got to change colors. I'm getting tired. Let's go black. Nope. Let's go green. Let's go whatever that color is. This is opposite. This is, it looks like gray. That's awful. Come on. Can't they come up with better colors? Where's purple? Ooh. That's a really fat purple. I don't know if I want to. Let's try fat purple. Opposite, hypotenuse. Wow, that is really fat. And this is adjacent. So I'm using O and H. So that's sine. So I'm going to do sine. Oh, this is so fancy. Of x is equal to opposite over hypotenuse, 30 over 50. So we have to use inverse sine in order to solve this, or we're just going to slide that sine over there. Don't you divide by sine, can't do it. Don't cross multiply, can't do it. It's crazy. So x equals the inverse sine of 30 over 50. Grab my calculator, go into inverse sine function of 30 divided by 50. And hit enter. 36.8698. X equals 36.8698. 698. Where am I rounded to? The nearest degree. So my answer is x equals 37 degrees. 1, 2, 3, 4, 5, 6. That's it. Almost done. So in triangle, ABC, where C is the 90-degree angle, there's A, there's B. I got to get rid of this. This is awful. I'll go back here. C is the 90-degree angle. And I just put A and B in there arbitrarily. It doesn't matter. AC is 12. BC is 16. 16. Find to the nearest degree the measure of angle A. Okay, there's A right there. We'll call that X. So that's opposite over adjacent. So that's going to be tangent. So tangent of angle A, or in this case I called it X, is equal to opposite, which is 16, over adjacent, which is 12, 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 which is 12. Kind of creepy, huh? I know. That's me. Move the tangent over. So tangent, -1 of 16 divided by 12. You guys still awake? Woo! You guys are amazing students. Tangent -1 of 16 over 12. So second tan. There it is. Forgot already. 16 divided by 12. So 16 divided by 12. Enter. 53.130. So X equals 53.13010. 310, blah blah blah. What if I said to the nearest degrees, minutes, seconds? What if I said to the nearest minute? What would this be to the nearest minute? How would I do that? Well, all you got to do is DMS it. Go over here and DMS it. See, notice it says take the answer and DMS it, and hit enter. And if I wanted to do the nearest minute, that would be, ooh, this is going to be tricky. Let's get the 53 down. I'll talk with that. So it's 53 degrees. Now, be careful here. Check this out. 53 degrees, 7 minutes, and 48 seconds. Now, most of you would round 48 seconds and just leave it as 7 minutes. But remember, that's 48 seconds out of a minute, or 48 out of 60, which is more than half. So this would be 8 minutes. Thanks for the added lesson, Mr. Krause, on mathematics. We really appreciate it. And we like you. Pfft, whatever. I take chocolate. By the way, Beret, chocolate was amazing. Love the fudge. I had some other amazing cookies over break, too. I don't remember who it was. And I only know that it's got the proper sweetness and density because I really don't know what it tastes like, but it has something good. I want to know how far across it is, this lake. I'm a surveyor. I want to know across this lake. So, lo and behold, there's opposite, there's adjacent, tangent. So, tangent, I don't know why I wrote S. Tangent of 32 degrees is equal to opposite, which is x, over adjacent, which is 175. Cross multiply, I get x equals 175 times tangent of 32. Grab the calculator. 175. So 175 times tangent of 32. And hit enter, and I get 109.352. So x equals 109.352. Great 2, Krause. 136, 136, da da da. That's a 6. Round to the nearest meter. Okay, well, x equals 109 meters. I think we're on the last problem. Oh, no, we're not. Son of a gun. I am a jerk. 28-foot ladder. 28-foot ladder is leaning against a house. Let me draw a sick house. All right, I live in a box, and I got a 28-foot ladder going to the side of that box from the ground. There's my angle. All right, so my angle is, I don't know. The bottom of the ladder is 6 feet away from the base of the house, and the ladder is 28 feet. Wow. That's going to be really steep. 6 feet away, and you're going to put a 28-foot ladder. You're going to feel like you're going to fall over. And I'm afraid of heights, so there's no way I would do this. So let me agree, I am definitely afraid of heights. Yeah. Ugh. So anyway, that's why I wouldn't jump out of a helicopter. By the way, who jumps out of a helicopter? Come on. You got to be out of your mind to jump out of a helicopter. Like, seriously. Screw loose. It's a perfectly functioning aircraft. Don't jump out. Just land and enjoy life. Opposite, adjacent, and hypotenuse. The two functions that are being used in this case are cosine. God, we haven't seen cosine in a while. So it's going to be cosine of theta, whatever you want to call it, is equal to adjacent, which is 6, over hypotenuse, which is 28. We're going to use the arc sine, the inverse sine. We're going to use it. We're going to bring this cosine over here. Not sine, cosine. And we're going to say, okay, theta is equal to the inverse, or arc sine, of 6 divided by 28. All right. Theta equals, I got to put that in my calculator, cosine -1. Either way, I'm never going to get this up before 8 o'clock tonight, and I've been working like crazy to get it done. 6 divided by 28. Hit enter. 70, that's a really steep one. 77.6. What's the nearest degree? Let's go with 78 degrees. All right. We're almost done. Find the value of theta. Oh, so we're going to round it to the nearest tenth. Oh, this is a mistake. This is supposed to say to the nearest 10 minutes. To the nearest 10 minutes. Oh no. I'm sorry. I forgot what we were doing here. So we're finding the angle. All we're doing is finding the angle. I'm sorry. I was thinking it was a different thing. So we're going to find the angle theta to the nearest tenth. Oh, look at that. I forgot I put these in here. This is awesome. So let's quickly go to the calculator. Secant cosecant. Where's my calculator? Where'd my calculator go? All right, so we're going to do cosecant, or inverse cosecant, of 5.296. 5.296. And hit enter. Well, that gives us 10.88 degrees. So x equals 10.88 degrees. But that's a reference angle. Now, the good news is it's in the first quadrant, so that's the answer. X equals 10.9 degrees. The next two are not going to be so easy. We're going to find a reference angle, and then we're going to have to figure out which quadrant we're in. So on this one, we're going to do second cotangent, or excuse me, we're going to get the inverse cotangent function in there, and we're going to do 1.359 and hit enter, and it's 36.346. So x equals 36.346. But that's a reference angle. So that puts us from 180 to 270. That puts us in this quadrant right here. There's my theta. So what I really want to do is add 180 to that to figure out what really theta is. Because I'm going to assuming if I wrote these directions correctly, it says theta's in the standard position. Oh, I should have said theta written in the standard position and its terminal side landing in the given quadrant. Bad directions. But anyway, add 180 to this. We're going to add 180. And we get 216 point, we're going to round this to the hundreds place, thousands place. So 216.347. 216, so x equals 216.347. And finally, we're going to do the cosecant, or the secant, inverse secant of 2.695, 2.695, and hit enter, and we get 62.219. 62.219, but we're in the fourth quadrant. We're in this quadrant right here, and so that's the 62. So what we're going to do, actually this time, we're going to subtract that from 360. So I'm going to do 360 minus the answer that I just got before, which is at 68, and I get 291.78. So 291.78 degrees. Ooh, that was a tricky one. Almost picked my nose there. Okay, great. Guys, you made it to the end. I don't think I'm actually testing on those last three items. I'll take a look on the test. If I am, we'll talk about it in class. Great job. Study hard. Memorize that first quadrant. And work hard, guys. Work hard. We only got a couple more days, and we're off for February break. You don't have to see this ugly mug anymore. This is Kraus Man signing off. Not signing off.